चलो, गुड इवनिंग। सो लास्ट क्लास में हम लोगों ने बात किया था बेसिकली डिफरेंट टाइप ऑफ फोर्सेस एंड मेनली वी हैव टू वर्क ऑन द फ्रिक्शन. दिस इज द मोस्ट important thing. So let's try to solve some basic problem based on friction. Okay. So first we will solve some basic problem on friction and then we will also try to introduce all different type of questions. Okay. So let's try to go for this. So this is a wonderful problem, and this problem is from a very nice book of mechanics, that is Eurodove. Okay, so let's try to solve this one. It's a wonderful problem and very analytical also. Not very high level of calculation, but analysis is very nice. Let's try to go for this. So what we have basically, so there is a one particular wedge and this angle is alpha. So, and we can assume this wedge is very heavy, so it is not moving. And there is a pulley on this particular wedge, and what we have basically two mass. This is my first mass, and this is my second mass. And the coefficient of this mass is basically m1 and this mass is m2. So what we have, the coefficient of friction between the mass and wedge is, let's say, k is the coefficient of friction. So this is your coefficient of friction, and this block is not going to touch with this particular surface. So it is just going up and down, something like this can be happen. The question is very important. There is not any another forces. Only weight is there, tension is there, but not any another forces. This particular wedge will rest with respect to ground, or with respect to ground. So it is not going to move. And what we have to do, we have to calculate what will be condition such that the particle m1 and m2 will rest with respect to this particular wedge. This is very interesting. What will be condition such that both the particle m1 and m2 remain rest with respect to this particular mass, this particular wedge actually. So how we will do this particular problem? So here you can think there may be two possible motion. One possible motion is m1 can we go downward? This is case one. And second possible motion is m1 can go upward. So what we have to do, we have to just make a provision. We should give the condition such that neither m1 or m2 will move with respect to this particular wedge. So this is very interesting, and this type of question you can expect in any good examination, including your IIT-JAM, NEET, and your JEST, JAM. Everywhere this type of question has come. After this question, I will do one question from JEST examination that has exactly same concept, but yes, arrangement is different. So let's try to go for this. So what we will do, we will just go for case one. When m1 will go downward, m1 will go downward. So if m1 will go downward, then obviously friction will be adjusted such that it will oppose the relative motion between this particular wedge and mass. So this is very important because the direction of friction will dependent on the direction of motion of m1. So let's try to go for this, to making the free body diagram, and we will just try to write the equation for. So case one, what we are going to do when m1 is going downward. Okay, so let's see what is going to happen. So यहाँ पर जो हो रहा है वो आप देख सकते हो कि this is my m1 and the weight is m1g. This will be my this angle will be alpha, this angle is alpha, so this will be m1g cos alpha. This is normal, ये हमारा normal होगा, because weight इसको नीचे pull कर रहा है, then obviously normal will act. So there is some normal against the force which is pulling to this particular surface. And what will happen? Tension will be go into this direction. This is tension. And yes, the another component of m1g will be come into this direction. That value is m1g sine alpha. Okay, so this is all about m1g sine alpha. Now, if it is going downward, then what will be direction of frictional force? The direction of frictional force will be in upward direction. The direction of frictional force must be in upward direction. Okay, so this is condition for m1 is going downward. तो यहाँ पर हमें कोई acceleration वगैरह नहीं calculate करना. We have to just write the condition. So when it will go downward, when the downward force will more than upward force. So what is condition? The condition is m1g sine alpha must be greater than tension plus frictional force. Must be greater than tension plus frictional force. और यहाँ पर कौन सा frictional force लगेगा? Obviously you will use kinetic friction, है ना? Because ये आपका motion हो रहा है तो you will use the kinetic friction. Then what will be your kinetic friction? आपका जो यहाँ पर kinetic friction होगा, that value is equal to k into normal, and that value is equal to k into m1g cos alpha. Okay, so what we can write? We can write m1g sine alpha must be greater than tension plus m1g k cos alpha. और इसको आप चाहो तो कुछ इस तरह भी लिख सकते हो. What will be that thing? That thing is basically m1g sine alpha minus m1g k cos alpha must be greater than tension. So this is for what? This is for m1 is going downward. Now this tension is not known to us, है ना? So now let's try to go for second particle. What is going to happen to the second particle? So when we are going for the second particle, then there is only two forces. This will be m2g और टेंशन किधर लगेगा? इधर लगेगा. अब ये नीचे जा रहा है, then it should be go upward. ये अगर नीचे जा रहा है तो इसे किधर जाना पड़ेगा? अपवर्ड जाना होगा. तो ये अगर अपवर्ड जा रहा है, that means tension must be greater than m2g. That means tension must be greater than m2g. और यहां से हमारे पास कंडीशन क्या आ रहा है? So this term is greater than tension, and tension is greater than m2g. A is greater than b, b is greater than c, then a will be greater than c. So this is the condition where m1 will go downward, है ना? So what do you have? You have m1g sine alpha minus m1g k cos alpha must be greater than m2g. So this is my first condition where m1 will go downward. लेकिन हमें निकालना क्या है? m1 move नहीं करे. So let's see how we will reach up to that particular point. And we have to give this condition mainly on m1 and m2. So mainly we have to give this condition on m1 and m2. So this is your first condition where m1 will go downward. Okay, let's try to go for the second condition when m1 will go upward. So let's try to go for, so this is my one condition. This is my first condition. So let's try to go for, ये समझ में आ रहा है यहाँ तक स्टूडेंट्स? ऑनलाइन वाले स्टूडेंट समझ में आ रहा है आपको? ओके, चलो अब दूसरा कंडीशन देखते हैं. What will be my second condition? Second condition is very interesting. When m1 will go upward. So यहाँ पर फिर से हमारे पास m1 है, वेट ऐसा ही लिखेगा लगेगा m1g. This value is equal to m1g cos alpha. This angle is alpha because this angle is given alpha. This is your direction of normal. This is your direction of tension. And this is your direction of the component of m1 into this direction. So that is m1g sine alpha. है ना? So this is the condition m1g sine alpha. Now you can see. आप दोनों में अगर आप ध्यान से देखोगे तो क्या हो रहा है? आप अगर दोनों में देखोगे तो m1g का डायरेक्शन, टेंशन का डायरेक्शन सेम है. And what is going to happen? There is basically you will see the direction of frictional force is going to change. So why frictional force is said to be what? Self-adjusting force. It will adjust itself according to motion. So it is nothing but what? Self-adjusting force. So इसको कैसे देखते हैं? So what will be direction of frictional force? Frictional force का direction क्या होगा? M1 will go upward. So frictional force will go downward. This is my frictional force. Okay. So what will happen? So this is for the, obviously, if it is go upward, that means tension will be greater than m1g sine alpha plus frictional force. Tension will be greater than m1g sine alpha plus frictional force. And what will happen? This tension must be greater than m1g sine alpha. The frictional force will remain same, the magnitude will remain same, but direction will different. So that value is equal to k m1g cos alpha. So this is my condition for m1. लेकिन यहाँ सिर्फ m1 की ही कंडीशन नहीं देखना है, हमें m2 की भी कंडीशन देखना है. So what is condition for m2? If you are talking about m2, then again this is my force, that value is m2g, this is my tension. Now this is going downward. What is meaning of that? Meaning of that, m2g is greater than tension. m2g is greater than tension. So what will happen? m2g is greater than tension. Tension is greater than this. A is greater than B. B is greater than C. That means you have m2g must be greater than m1g sine alpha plus k m1g cos alpha. And this is condition where m1 will go upward. m1 will go upward. Now look at this condition. This is your condition 2. This condition will tell you that m2 will go downward or m1 will go down, will go upward. Another condition, what is that condition? m1g sine alpha minus m1g k cos alpha is greater than m2g. So this condition, m1g sine alpha minus m2g k cos alpha must, sorry, m1g k cos alpha actually. So this value is m1 gk cos alpha is equal to m2g. So this is your first equation. Now अब आपको क्या देखना है? ये नहीं होना चाहिए, ये नहीं होना चाहिए. This is very important. If this is going to happen, there is motion. If this is going to happen, there is motion. हमें क्या करना है? ना ही ये कंडीशन चाहिए, ना ही ये कंडीशन चाहिए. So what will be condition? So obviously the condition is, ये अगर इससे ज्यादा होगा तो क्या होगा? नहीं हो पाएगा. That means you have m2g must be less than m1g sin alpha plus k m1g cos alpha. और m2g इससे अगर छोटा है तो मोशन हो रहा है तो इससे बड़ा होना पड़ेगा. So that should be bigger than this. So this value is equal to m1g sin alpha minus m. So you have m1g sin alpha minus m1gk cos alpha. And this is your condition where not any particle is going to move. So you can just cancel out and we can write it in term of ratio. So that value is equal to sin alpha minus cos alpha, k cos alpha must be m2 by m1, and this will be sin alpha plus k cos alpha. So this will be your answer. ओके सो इस तरह के प्रॉब्लम में हम कैसे देख रहे हैं, हम देख रहे हैं कि पहले मोशन हो किस तरह से हो सकता है, बिकॉज देयर इज नॉट ओनली वन मोशन इज पॉसिबल, यू हैव अ कंडीशन ऑन m1 एंड m2. m1 एंड m2 का जब तक कंडीशन नहीं सेटिस्फाई होगा मोशन नहीं होगा. तो कई बार ऐसा भी क्वेश्चन एग्जाम में दे देता है, आपको ये थोड़ा देखना चाहिए कि आपसे दे दिया m1g और m1 की वैल्यू दे दी, m2 की वैल्यू दे दी, और m1 और m2 की वैल्यू कुछ ऐसा दिया कि वो इस रेंज में आता है, और आपसे पूछ रहा है कि व्हाट विल बी एक्सेलरेशन. मोस्ट ऑफ द पीपल क्या गलती करते हैं वो मैं बताता हूं. मोस्ट ऑफ द पीपल करते हैं कि किसी भी एक डायरेक्शन में उसके मोशन को ले लेते हैं, किसी भी एक डायरेक्शन में उसके मोशन को ले लेते हैं, और अगर आपकी एक्सेलरेशन नेगेटिव आ जाती है तो आप एज्यूम करते हो कि ये ऊपर जा रहा है. This is wrong thing. What you have to do, you have to just check whether this mass, the ratio between mass is sufficient or not, which can overpower the frictional force or not. This is very important. So, इस केस में अगर सपोज करो तुम्हारे पास कुछ इस तरह का नंबर आ जाए, then what will happen? There is not any acceleration. Both particle cannot be moved. So, ऐसा जरूरी नहीं है कि अगर फ्रिक्शन हो तो पार्टिकल मूव करे ही करे. It will depend on condition, and that condition can be given by m2 by m1. Okay, so this is one of the very wonderful problem. ये IE-RODOP का प्रॉब्लम है. आप जब चाहो फ्रिक्शन को समझने के लिए, मोशन को समझने के लिए आप इसके ऊपर वर्क कर सकते हो. ठीक है, सो इसी कारण प्रॉब्लम करने से पहले हमें देखना होता है कि विच कंडीशन इट इज गोइंग टू सेटिस्फाई. आप डायरेक्टली सीधा सीधा इक्वेशन मत लिख लो, है ना. This is very interesting. Any doubt? Any doubt? Doubt है कोई? ऑनलाइन वाले बच्चों जो ऑनलाइन क्लास कर रहे हो, कोई डाउट है? क्लियर है ना. सो देखो इसी लेवल पर एक क्वेश्चन आया था 2-3 साल पहले, जेस्ट में क्वेश्चन था. इट्स अ वंडरफुल प्रॉब्लम. So let's try to solve this one. So basic idea is same, but देखते हैं कैसे इसको solve कर सकते हैं. So this is very interesting. So what we have basically a wedge, and again this wedge is so heavy such that it cannot move, and there is enough friction between surface and this particular wedge such that it is not going to move. And there is a mass m. There is a mass m. And coefficient of friction is mu. This is your coefficient of friction. Okay. And this angle is theta. This angle is theta. Okay. And what we are going to do, we are just giving a horizontal force, exactly weight of the mass. एक हॉरिजॉन्टल फोर्स दे रहे हो, वो कितना है, mg है. जो वेट है उसी के इक्वल आप एक हॉरिजॉन्टल फोर्स दे रहे हो. ठीक है. सो नाउ द क्वेश्चन इज व्हाट इज कंडीशन. कंडीशन ऑन tan theta. What is condition on tan theta such that mass m will not move with respect to wedge, with respect to wedge or prism, whatever you can say. Okay, so this is wonderful problem. This is wonderful problem. The concept is exactly same. जो हमने concept लिया था वो exactly same concept है. Now देखो हो क्या रहा है. Let's try to go for making the free body diagram. Once we will go for the free body diagram, then we can analyze how we can solve it. So obviously this is my x-axis and this is my y-axis, so there is not any problem. So what we are going to do, we have, this is your theta. So this is your mass m. There is two forces. One force is in vertical direction, that is nothing but mg, and this is my x-axis, so this will be my y-axis. So this is your normal, and this is your mg cos theta. This is angle is theta, and this is your mg sin theta. Okay, so this is all component along x and y direction. So this is my x direction. I can assume this is my x direction, this is my y direction. This is the component of vertical force. ये किसका component है? Vertical force का component. So if this horizontal force will not there is a only chances either particle will go downward or it will remain stationary, depend on what is the frictional force. What is the basically mu? What is mu? If mu is very irrelevant, then it obviously it cannot go downward. लेकिन यहां पर एक horizontal force है जो exactly weight के बराबर. So let's see what is going to happen. So this is my horizontal force. So I am just using the yellow color for this. So this is my horizontal force. This will be mg. Okay. If this angle is theta, then this angle is what? 90 minus theta. Then what will be component of mg into this direction? Then this will be mg sin theta. And this value is 90 minus theta, so this will be mg sin theta. The another component is basically mg cos theta. Now look at here. Now you have these two forces acting in a opposite direction. So there may be chances that this particle can go upward. If cos theta is greater than sin theta, then it will go upward. And obviously friction will also work here. Friction is also there. So obviously if it is go upward, the frictional force will go downward. So if this force is enough such that it can balance this one as well as frictional force, then particle can go upward also. And if this force is going to balance this one and frictional force, then it can go downward. So again, what you have to do? Again, you have to discuss the two cases. This question was asked into your JEST examination. This was asked into your JEST examination. Wonderful problem. Wonderful problem. So again, if you have two opposite forces and there is a chance, if we are varying the theta, then this particular thing is going to, the condition is going to change. Agreed? So when we have these things, and again what we have to do, we have to work with two conditions. So what will be your first condition? समझ में आ रहा है ऑनलाइन वाले बच्चों? These all are very mature question, है ना? समझ में आ रहा है?
Yes, sir.
है ना? चलो. So now what is going to happen? Let's try to do this thing. So case 1. When block will go downward. Go downward. Case 1, when block will go downward. अगर block downward जा रहा है तो क्या होगा? If block will go downward, then frictional force will be in which direction? अगर block downward है तो frictional force किस direction में होगा? Upward direction. Then frictional force will in upward direction. So what is condition? The condition is mg sine theta must be greater than you have mg cos theta plus frictional force. Mg cos theta plus frictional force. Okay. And what is your frictional force? That is mu into n. And now n is here. Your n is not only mg sine theta, rather mg sine theta plus cos theta. This is your normal. So what will happen? Mg sine theta must be greater than you have mg cos theta plus frictional force coefficient of friction is mu, and that value is mg sine theta plus cos theta. Mg sine theta plus cos theta. Okay. So this is a really very wonderful thing. So now we have to talk about the theta, tan theta. We have to condition on tan theta basically. So अगर मैं tan theta के लिए कर रहा हूँ, then what I have to do? I have to just mg will be cancelled out from everywhere. Just divide with the cos theta. So what will happen? Tan theta must be greater than 1 plus mu tan theta plus mu. So I can take tan theta into this direction. हालांकि इसको negative करते हैं. So what you have? You have tan theta and you have 1 minus mu must be greater than 1 plus mu. So your tan theta must be greater than 1 plus mu, 1 minus mu. Okay. So if you have this condition, you can change this theta. You can change this theta. If you have this condition, then what will happen? Mg will go downward. The block will go downward. This is your condition. Okay. Tan theta is greater than 1 plus mu, 1 minus mu. So let's try to go for a second condition. Okay. Clear है यहाँ तक? Online people, are you happy?
Yes, sir.
Chalo. So let's try to go for next one. So this is mg will go downward. Now the case 2. So we are just going for the case 2. Case 2 where mg will go upward. Mg will go upward. This is all about what? Your case 2. So what is going to happen into this particular case? Let's try to go for this. So again, what we have this particular mass. This is your, sorry, this angle is theta, not alpha. So this angle is theta. Obviously, this is my mg, and another is your, this one is mg cos theta, another is what? Mg sine theta. And there is a horizontal force. The horizontal force is basically, this one is mg, one component will become, this angle is also theta. So this is 90 minus theta. So you can take plus mg sine theta. All forces will remain same. And this force is what? Mg cos theta. Now this block is going upward. ये block किधर जा रहा है? Upward जा रहा है. So what will be direction of frictional force? The direction of frictional force is downward. So what is condition if it is going upward? The condition is basically mg cos theta must be greater than mg sine theta plus frictional force, and what we have, mg cos theta must be greater than mg sine theta plus what you have? You have basically mu and mg, and this will be cos theta plus sine theta. Okay, so you can see normal force itself is increased. This is your direction of normal force. Okay, so normal force is increased. So again you can see only one force is changing its direction according to its motion, that is frictional force. All other forces will remain same. So it's a very wonderful thing. So why we always said that frictional force is self adjusting. Frictional force kya hai? Self adjusting. So again we have to talk about tan theta. Then what we will do? We will just divide with cos theta on both sides. Mg will be cancelled out. So this will be 1 and that value is equal to tan theta plus mu plus mu tan theta. You can take it into this direction. So 1 minus mu upon 1 plus mu must be greater than tan theta. Okay, so in this condition, this will go upward, isn't it? So, but what we have to do? We have to find a situation where the particle will neither go upward nor go downward. So what will happen? Tan theta must be, this is less than, then this will be greater than 1 minus mu 1 plus mu. And here you can see tan theta is greater than, so it should be less than this particular thing. So that value, and you can also give the equality sign, that will be 1 plus mu 1 minus mu. So this is wonderful question. Ask in any quality examination. Ask in any quality examination. Frictional force is very interesting. Frictional force is very interesting and you can easily solve this type of problem. Okay? कोई doubt है?
No, sir.
No. Okay, good. तो ऐसे क्वेश्चन आएंगे तो आप गलत मत कीजिएगा, उसको टाइम देना होता है एंड यू हैव टू एनालाइज. जब भी आपसे ये पूछ दे कि पार्टिकल रेस्ट पे है, देन यू हैव टू डिस्कस ऑल द मोशन and then you have to identify what is condition that particle will remain at rest. This is a wonderful problem for TIFR, for JEST, and even for net gate, even maybe IIT-JAM, IIT वगैरह में भी ऐसे क्वेश्चंस आते हैं. ठीक है, let's try to go for this. Let's go for next problem. Okay, first I will go for the simpler version, then we will go for the little bit main version which I want to discuss. क्लियर है भाई? चलो, एक हमने अपने +2 में क्वेश्चन किया हुआ है, ये बड़ा इंटरेस्टिंग क्वेश्चन. दिस इज योर रिजिड वॉल, बट आई एम नॉट इंटरेस्टेड इनटू दिस क्वेश्चन. मैं इस क्वेश्चन में इंटरेस्टेड नहीं हूं, मैं इसके बाद जो क्वेश्चन आ रहा है उसमें ज्यादा इंटरेस्टेड हूं. सो दिस इज अ रिजिड वॉल, यहां पर रिजिड वॉल है, एंड व्हाट इज गोइंग टू हैपन? We have to apply, and this is some mass m, and this is vertical wall. Okay, this is vertical wall, and there is, we are just going to apply some force F. We are just going to apply some force F, and there is a coefficient of friction. The coefficient of friction is mu. Coefficient of friction क्या है? Mu है. And what we have to do? We have to find the minimum force F. If you will press it very high with high force, then it will not go downward. What should be the minimum force F such that this block will remain at rest with respect to wall? This is my question, and this is very simple one. So it will not come into your exam. ये आपके एग्जाम में नहीं आएगा. तो एग्जाम में जो आएगा वो इसके बाद करेंगे. Two questions we will discuss like that. So this is your force F, and what we have to do? We have to find the minimum force F such that this block is not going downward. Okay. So this is this weight is always there, mg. Yes. Now, what should be the direction of frictional force if it is rest here? What should be the direction of frictional force if it is rest here? Upward direction. How do you define? You just ask a question. If there is not any friction, then what will happen? This particle is bound to be downward direction. So frictional force will in upward direction. This is your frictional force. Now, if we are pushing this particular block, then this block will push to this particular wall. So there is some reactionary or normal force in this direction. Okay, so there is some reactionary or normal force in this particular direction. Okay, so what will happen? So you have to just take a condition. So for the limiting case, mg must be equal to mu s, and this is your static friction, mu s into n. Yes, mu s into n. Agreed? Now, what will be n? So, obviously there is not any motion into the horizontal direction. So, my F is equal to n. So, what will happen? I can replace F with n with F, and we have mg is equal to mu s into F. So, F must be equal to mg by s. Okay, F must be equal to mg by us. So this is the condition. This is the minimum force. If your force is less than this, then this particle will go downward. So this is your minimum force you can see. So you can write something like this. F must be less than equal to F must be greater than or equal to. Okay, F must be greater than equal to mg by s. So then this block will remain rest. Okay. Now let's try to do this problem, next problem, which is very interesting. What I am going to do, I have a very interesting arrangement. Now instead of this particular wall, I have a block, and this block has capital mass m. This block has capital mass m, and there is a small block m, and this surface is frictionless, and there is some coefficient of friction, that is mu s here. Okay, but this surface is frictionless. Now question is, what will be minimum force F? What will be minimum force F such that this particle will not fall down? Such that this particle will not fall down. So now what will happen? If this surface is frictionless, even if you will give the little push of this particular thing, this block will move. So you have to take this thing as your, this particular motion as your consideration. So what is going to happen? How we will try to solve the problem? This is very interesting. Okay, so let's try to solve this particular problem. Then obviously, what will be direction of? So we can just make a free body diagram for it. This will be obviously mg. Okay, if this friction will not there, it is bound to go downward. So obviously frictional force will in this direction. Okay, and we are giving some force here. So we are pushing this particular block. So this block will push to the capital block, and capital block will again push to this particular small block. So this is my direction of normal. Okay, and this is for the, basically for the smaller block. And what will happen? The complete system is moving with acceleration a. Okay, and this block will also pushing it. So this has some normal force n on the capital M. So on a capital M, what we have? On a capital M, basically we have, on a capital M, we have a normal force, and obviously it is moving with acceleration A. Okay. So now, again, what should be frictional force? What should be, what is condition such that this block will not go downward? क्या condition है कि ये block downward नहीं जाएगा? There is only one condition, that mg must be equal to frictional force. mg must be equal to frictional force, and for the minimum force, this mg must be equal to mu s into n. So now what we have to do? We have to find the value of n. How you will find the value of n? Okay, so from there we can find, so here f is equal to, I can write m plus capital M into A. Yes, f is equal to m plus capital M into A. Okay, agreed? And from there we can find the normal force. So here n is equal to m into A, isn't it? And what we will do, we will just going to divide this thing, and we can write normal force in term of F. Same just like here, we have written the normal force term of F. Okay, so what we will do, we can find normal force. So N by F is equal to M by M plus M. So what will be your normal force? Your normal force is equal to M plus M into F. And now you can put it here. So the condition will be, from there we have mg must be equal to mu s, and here we have m upon m plus m. And now we can easily calculate the f. So for the limiting case, f must be greater than, we have mg m plus m by small m, isn't it? कुछ गड़बड़ हो रहा है क्या? Just a minute. ओह सॉरी, यहाँ पर कैपिटल एम होगा ना. नॉर्मल फोर्स इज इक्वल टू कैपिटल एम. सॉरी, दिस विल बी कैपिटल एम. जस्ट चेंज इट. दिस विल बी कैपिटल एम. This will be capital M. This will be also capital M. This will be capital M. And this will be again capital M. Sorry, this will be capital M. So this will be also capital M. This will be your capital. Sorry, because it has capital M now. So this will be capital M. So now you can find this value, and this value is equal to कैपिटल एम. अब ये बताओ मुझे कैसे पता चला कि मैंने कुछ गलती की है? हाउ आई नो दैट आई हैव डन समथिंग रॉन्ग? हाउ आई नो दैट? बाय म्यू. कैसे मुझे पता चला कि मैंने कुछ गलती की है? एनीवन, कोई मुझे बता सकता है? हाउ डू आई नो दैट आई हैव डन समथिंग रॉन्ग? जस्ट watching this thing, I think that okay, I have done something silly, and I have now corrected this capital small m to change with capital M. How I know that? कोई स्टूडेंट बता सकता है कैसे मुझे पता चला कि मैंने कुछ गलती की है? Look at here, it's a very interesting. क्योंकि मुझे ये आंसर पता है, तो I can check whether my answer is correct or not. If I will write this expression something like F must be greater than mg upon mu s, and this value is equal to 1 plus small m by capital M. M and M, 1 plus small m by capital M. Now, how I will convert this problem to this one? कैसे आप convert करोगे इस problem से इससे? How you will convert this problem to this one? एग्जाम में 4 ऑब्जेक्टिव आते हैं और उस ऑब्जेक्टिव को देखकर आप बता सकते हो कि यार ये ऑप्शन की तरफ हमें जाना चाहिए. How you, if you know this result, this is very famous result and everybody know this result. What will happen? If I assume this mass is infinite, so it cannot move. What is meaning of infinite mean? If I am assuming this is a wall, that means I am assuming this is an infinite mass which cannot be moved. So if I assume this mass is infinite, then what will you can check? The capital M tends to infinity. This term will be 0 and you have F is greater than mg upon mu s. F is greater than mg upon mu s. Exactly same answer you have from here. Isn't it? So if you are assuming this thing, you can have this sort of information. Okay? So this is a wonderful problem. ये भी आपके एग्जाम में कहीं भी आ सकता है, and you can see if you will calculate the normal force here by calculating F, this normal force. So now you can see here force and normal will same, but here the normal force is going to change. It is just going to change. है ना? So they can be also asked in the MSQ, what will be normal force? What will be the final condition? So there may be one and more than one thing can be answered. Okay? So this is a really wonderful problem. कोई doubt है? Online students, कोई doubt है? Okay, chalo. So let's try to go for our next thing is very interesting, that we will talk about little bit of a equation of constraint. Okay, so let's try to go for how we will use equation of constraint, and then tomorrow we will finish the final version of this particular problem. है ना? चलो. Now look at this particular Atwood machine system, pulley and mass system. Suppose you have this particular, there is a pulley, and I assume that this pulley is very small and it has not any mass. So this is just a, suppose I have M1, I have M2. Okay. So one is M1, another is M2. So most of the people will solve this problem by writing something like this. So this will be, and this mass, this string is massless. So this is just something like this. So most of the people will solve this particular problem by writing this equation. This is your M1G, this is your M2G, this will be tension, this will be tension. Okay? So you just assume that, okay, this will go downward, this will go upward. So what will happen? M2G minus T is equal to M2A. Okay? And it will go just upward. So you will write T minus M1G is equal to M1A. Okay? And you can easily solve this particular problem. This tension will cancel. You can get A, that value is M2 minus M1 G upon M2 plus M. Absolutely correct. Now, I just want to know some fundamental question. How do you know that this acceleration is same? How do you know that these two acceleration will remain same? Obviously, this is so simple problem where you can easily say, okay, yes sir, this will move upward the same distance in the same time, so this will move downward in the same distance with the same time. So we can take we can say that both acceleration is same. It is so obvious, so trivial, but when complicated problem will come into picture, then obviously you will find a real difficulty. So why we have to go with the fundamentally using the equation of constraint. So let's try to go for this particular thing. How, if I will solve this problem, then how I will solve this problem? I will solve this problem m1g minus t is equal to m1a, a1. I will say its acceleration is a1. And second, I will solve m2g minus t is equal to m2a2. So how many variables is there? 1, 2, and 3 variables are there. And for solving this particular problem to get the unique solution, you need one more equation. If you have 3 variables, then you need 3 equations. And what is the third equation? Third equation is nothing but the equation of constraint. So what is the equation of constraint here? Equation of constraint here, we can assume this distance is x1, this distance is x2, and this is your pi r. So length of a string is always fixed. So what will happen? Length of a string is always fixed. So you have x1 plus x2 plus pi r must be equal to length of a string. And if we are going to take the derivative or twice with respect to time, then we have get x1 double dot plus x2 double dot is equal to 0. And from here, we can get a1 is equal to minus a2. So from here, from this particular equation of constraint, mathematically we can say my a1 is equal to minus a2. So whatever be the direction of a1, or direction of m1, m2 will go into opposite direction. So I haven't assumed anything that which particle is going downward and which particle is going upward. I have just written the equation of motion. I have just taken this is my positive, this is my positive, this one is my negative, this one is my negative, and I have written my equation of motion, and I have used equation of constraint, and then I can easily solve. I can put a1 is equal to a, then a2 is equal to, I can put minus a, and I will get exactly same equation, isn't it? Exactly, more or less same equation. You can get m1g minus t is equal to m1a, and this value is equal to m2g minus t is equal to minus m2a, and now you can easily solve this problem. Okay, and you will land at this particular point itself. Okay, this is very trivial, very simple, but when you have more complicated problem, अगर आपके पास ज़्यादा complicated problem है, तो आप कैसे बढ़ोगे, तो आप कैसे चीज़ों को देखोगे, उसके लिए हमें एक और equation of constraint को समझने की जरूरत है. So let's try to go for next one. ये clear है ना, this equation of constraint? Let's try to go for next one. This is very interesting. The same Atwood machine, this is your M1, this is your M2, but what is going to happen? The whole system is moving with acceleration a0 in upward direction. The whole system is moving in acceleration a0 in upward direction. So, and this is my ground. This is my ground. With respect to ground, acceleration of m1 is a1, acceleration of m2 is a2. So both are moving in upward direction. So what will be relationship between a1, a2 and a0? What will be relationship between a1, a2 and a0? Okay, if whole thing is moving upward, but with respect to this is going downward, this is going upward. So it may be very complex thing if you want to visualize. So there is no need to visualize anything. What I will assume? I will assume this is my x1. I will assume this is my x2, and I will assume this is my x0. Okay? And what will happen from here? Again, this length of a string is same and constant. Then what you can have? This length is x0 minus x1 plus this is your pi r plus this length is x0 minus x2 must be L. x0 minus x2 must be L. And again, if I can differentiate twice, then what will happen? x0 double dot minus x1 double dot plus x0 double dot minus x2 double dot must be equal to 0, and you can have 2 times a0 is equal to a1 plus a2, and a0 is equal to a1 plus a2 by 2. So this is a very interesting problem, and you can easily use this constraint. So two constraints are very important. One is all about this particular Atwood machine, this one, and another is all about this one. And with the mix of these two, you can solve the complicated to complicated problem. For example, let us try to go for next one. देखते हैं इस problem. Very interesting. So this is your M1, this is your M2, this is your M3, this is your M4. So how you will find the acceleration of M1, M2, M3 and M4? It's a very difficult. Okay. So now we can easily find this thing, these two constraints. So suppose I can assume it has acceleration A1, it has acceleration A2, it has acceleration A3, it has acceleration A4 without assuming any direction. I am not assuming any direction. I assume that this will go downward, then whole this thing will go upward. So up to this point, so what is going to happen? This composite system will go with acceleration A0 with upward direction, and this composite system will go direction with A0 in downwards. Okay. So what will happen? A0 can be written as A1 plus A2 by 2. Yes. And second, hence it is A0 in positive direction. I can take A0 in negative direction. Minus A0 is equal to A3 plus A4 by 2. And from there, you can have A1 plus A2 plus A3 plus A4 must be equal to 0. And now you can write your equation of motion, and you can have this constraint, and you can solve the problem. Okay. So it's a very interesting that how you are using the equation of constraint. हालांकि आपके लेवल पर इतने क्वेश्चन नहीं आते हैं इक्वेशन ऑफ कंस्ट्रेंट में, but this is the thing where you can easily use all about your equation of constraints and you can solve the problem. Okay. So you can see this thing. Any problem? Online students, कोई problem है? No. Okay. So we have, so just go and revise all this thing. So tomorrow I will finish some, we will do some more problem on equation of constraint, and then we will just go for basically little bit of pseudo force and all this thing, and finally we will finish the basic of Newton's law. Okay. So this is Very important. If you are a student of physics, at least you should know all this thing from the very basic level. Okay? And this can be came in any examination, in any interview, any examination, anybody can ask you, because this is very fundamental problems. Okay? Obviously not graduate level, not master's level, but yes, this is school level, but very important. Okay? Thank you.
Thank you, sir.
Thank you.